right, welcome back year 10. So here is our second salt preparation method, and this time, rather than making an insoluble salt, we're going to make a soluble salt. And there's two ways to do that. The one we're going to cover today is the one where you use an insoluble reactant, an insoluble base, to make a soluble product. So that tells you a lot about what your equation will look like, just like last time. We're going to have a soluble product, so you know it'll be aqueous. And you're making it from an acid and an insoluble base. So your reactants are going to be an acid, which we know are always aqueous, and a base that's insoluble, so solid. These are going to give you a soluble salt and water. Okay. The common example used in textbooks is always copper sulfate, and that's the one we would have done in class. So if we were going to make copper sulfate, or CuSO4, we have to choose an acid that contains the sulfate group. I'll just color that in blue. And the acid that contains sulfate is, of course, sulfuric acid. Formula H2SO4. Okay. Next, we need a base that contains copper. Now you have a couple of options for bases. You can use oxides or hydroxides. We would use copper oxide in class. So copper oxide, CuO solid. Okay. These two react, the copper and sulfate come together, leaving us with H2O. All right, simple enough. But as you know, that's not what you're going to be asked on the exam. They want to know the method. So how do we go about preparing and you know what it's going to be, pure, dry sample? Just like last time, it starts simple. You just mix your reactants, but then separating and purifying are going to be a bit different this time because our salt is aqueous. Okay. Now often because you're reacting a solid with a solution, the first step in many of these experiments is heating up the acid. You wouldn't want to use a Bunsen burner for this because you don't want to release acidic gases into the air. But you could use a hot plate, or even in class we would use a hot water bath and put a test tube of sulfuric acid in that. But I'm just going to say warm the acid to speed up the reaction using any safe method. You could just say a hot plate to keep things easy. So we'd have our sulfuric acid in a little beaker. And warm it up. All right, once you've done that, you're ready to do your reaction. So step 2, you need to add copper oxide to your acid. Just like in the previous method, you'll want to stir or agitate the solution. And you'll want to add enough copper oxide that you end up with excess on the bottom. And we'll see why we do that in a minute. So we'll have H2SO4, we add copper oxide until you actually see a pile of this black solid. And the reason for that is that we want our whole solution to be just copper sulfate. We don't want any excess acid. And the reason for that is it's very easy to separate a solid from a solution. You just filter it. But to separate acid, which is dissolved, from your salt, which is dissolved, is very hard. If you just removed the water, you'd still be left with these two. If you filtered, you'd still be left with these two. We have to use up all the acid. And the only way to make sure all the acid is reacted is to have extra or excess CuO. Okay, so we've done that now. There's no acid left, which means we can filter out the excess. Okay, so just like last time, a good old friend, the filter paper in your funnel, and a conical flask. Okay, all that copper oxide will get trapped in the filter paper, and your lovely copper sulfate solution will be down here in the filtrate. It's wet, of course, it's dissolved in water, so you've got tons of water there. But you've separated it from the copper oxide, which is the important part. Now, here is where the method can deviate, and you can have sort of the simple method or the more difficult one. So I'm going to start with the simple and then show you the more complicated one. All right. Simple method is if you think this is pure, if you think this is really, really good copper oxide and there weren't any impurities in it, so you have got lovely copper sulfate, then you're pretty much done. You just take that solution, you can throw away the copper oxide, we don't need that. Take the solution, put it into a little evaporating basin, leave it in a warm place. All your water will leave. And over a couple days, you'll get lovely diamond-shaped crystals of copper sulfate. Done. Okay. So this is just a warm, dry place. To evaporate the water. Okay, now that's lovely if it was pure, that little caveat I said if it was pure. But sometimes they give you a question where one of your reactants, either the acid or more likely the solid copper oxide, had some impurities in it. Now imagine for an instant that some of those impurities were soluble. So I'm using this green. Those soluble impurities would be down here, messing up your sample. So if that's the case, then we need to do something called crystallization. And it will give us a few extra steps. So to do crystallization, you need to saturate this solution. And the way we saturate a solution is by heating it with a Bunsen burner. Heat that solution to remove about half the water. So you're left with a really concentrated copper sulfate. You've still got your impurities, but a lot of that water has gone. So we heat to remove some, not all, some water until the solution is saturated. Just move this up a little bit. There we go. How do we tell it's saturated? Well, you usually can see a few little crystals start to form on the side of the basin. Okay, if you can see that, you know it's reached the crystallization point. Okay, now here's where the really clever part happens. This is saturated for the copper sulfate, but it's not saturated for the impurity. Think about it. You've got tons of copper sulfate in there, but only a couple little particles of impurities. So if you then remove the Bunsen burner or you take your evaporating basin off and put it on a heat-proof mat to cool, as it cools, the solubility will decrease, which means crystals will form because they can't stay dissolved at that colder temperature. So you've got your really concentrated solution, it's cooling down, and you'll get, in real time, you won't have to wait days, it'll just take a couple minutes, some lovely copper sulfate crystals. And those impurities, they're left behind in the solution. So your final step is to just separate those crystals. And you can use, even some mark schemes even just say you can like take tweezers and pull your crystals out. I prefer something a little more standard and just filter them, okay? So get your filter, get your funnel and filter paper back out. The crystals will get trapped here. And that little bit of solution containing your impurities will come through. So these were our impurities. And you're left with copper sulfate. These might still be a bit damp, so you might want to dab them dry with paper towel, or you can again just leave them in a warm place to dry. Okay, so this one is a little bit more complicated than the first one we did because of this extra bit. Remember, this whole section here was called crystallization. And I've got some nice YouTube videos that you can watch to see what that looks like in action. All right, thanks for watching.